Okay, so Chapter 2, Section 8. This is Part 2 of the video, Rewriting Equations and Formulas. Sometimes this is also referred to as solving literal equations. And so yesterday in the video, you looked at how to take an equation that contains more than one variable and use the skills that we've been developing to solve it for a specific variable. So today we're going to look at a few more examples that are a little bit more challenging. So the first example we're going to look at, we're going to solve for v. And the equation or formula we're going to do this for is the density formula. Density is equal to m over v, or mass divided by volume. So you'll notice in this case we have to solve for v, which is in the denominator of a fraction. So our first step is to get it out of the denominator. Because v is dividing m, to get it out of there we do the opposite. We multiply both sides by v. So this is going to get canceled. Okay, that's going to get your v variable out of the denominator, leaving you with m. And then on the left side, we have v times d, which we can just simply write as vd. Well, we're not done yet. We got the v, our variable we're solving for, out of the denominator, but we still need to get it by itself. So v is being multiplied by d, so we do the inverse of that. We divide by d. Whatever we do to one side, we do to the other. Now these cancel, because d divided by d is 1. We're left with 1v equals m over d. And there you go, that's your final answer. So to find the volume, you could calculate that by taking the mass of an object and dividing it by its density. Let's take a look at another example. Example 2. Here we're going to solve for vf. Now sometimes subscripts are used to indicate differences in variables. So in this problem, we're going to be solving the acceleration formula, which is vf, that stands for final velocity, minus vi, which is initial velocity, all over t, which stands for time. So this is a formula used to calculate acceleration, or how much an object speeds up or slows down. So you calculate that by taking the difference in the initial velocity and final velocity and divide that by time. So in this case, we're solving for vf. We want vf by itself. So we ask ourselves, well, what's being done to vf? vi is being subtracted from it, and then it's being divided by t. So we do the opposite in the opposite direction, opposite order. So the opposite of dividing by t is multiplying by t. So we multiply both sides by t. Okay, these are going to cancel, leaving you with the numerator, vf minus vi. And on the left we have t times a, which we can just simply write as ta. So we're almost there. vf is being, or vi is being subtracted from vf. So to get vf by itself, we have to get rid of this negative vi. So the opposite would be to add vi. Whatever we do to one side, we got to do to the other. So combine these together to 0, leaving you with just the vf all by itself, which is what we wanted. And then ta plus vi, that's just how we write it. ta, t times a, plus vi. And that would be your final answer. So if you wanted to calculate the final velocity of an object, you can do that by taking the time, multiplying that by acceleration, and then adding its initial velocity. So we're going to take a look at one more example. And the directions you'll find in your assignment are either going to be to rewrite the equation in function form, or it might also say to write the equation so that y is a function of x. So either way, no matter what direction you're given, you're basically being asked to do the same thing, and that is to solve for y. So you're trying to get y by itself. So let's look at this example. Let's say we have 6x minus 3y equals 12. Okay, we want y by itself. So we need to get rid of this negative 3 that's being multiplied by y, and we also need to get rid of this 6x, which is a positive 6x, so it's being added. So we do the opposite in the opposite direction. Our first step is to get rid of this 6x. Okay, whatever we do to one side, we got to do to the other. Bring down the equal sign. By taking away the 6x here, we're left with negative 3y. So we're one step closer to y being by itself. On the right side, 12 minus 6x, we just simply write it like that, 12 minus 6x. Okay, that is not 6x. These are not like terms. You cannot take 6x's from 12 because 12 doesn't have any x's to give. So you just simply write it like that. We still need to get y by itself. It's being multiplied by negative 3, so the inverse of that would be division. Division by negative 3. Whatever we do to one side, dividing this side of the equation, means we have to do that over here as well. Divide this side by negative 3. So the whole sum, or actually in this case, this difference needs to be multiplied or divided by negative 3. Anytime that happens, that's kind of the same as taking, actually it is the same as doing 12, let me write 12 minus 6, is doing 12 divided by negative 3 and negative 6x over negative 3. You can kind of think of it like that, where you're dividing every term by negative 3. The whole thing getting divided by negative 3 means to take each thing individually and divide it by that. So we do 12 divided by negative 3. That's negative 4. And then negative 6x divided by negative 3 is positive 2x. And that would be your final answer. So we solved for y. We rewrote the equation so that y is a function of x.